Hello friends, today we are guiding you to prepare interview questions on Python. In comments you can share the topic of your interest. Our team will prepare the video for you. Before continue to our session, we request you to join our channel for all the latest updates. Our team of technical and subject matter experts are working hard to create valuable content just for you. So please make sure to hit the subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. How do you handle exceptions in Python? In Python, exceptions are handled using the try, except, else, and finally blocks. These blocks allow you to catch and handle errors gracefully, preventing the program from crashing due to unexpected situations, while ensuring that necessary cleanup or final actions are executed. Basic syntax: try : code that may raise an exception result equals 10, 0 # this will raise a zero division error except zero division error as e : code to handle the exception printf error else : code to execute if no exception occurs print no errors occurred finally : code that will always execute whether an exception occurs or not print execution completed. Try block: you write the code that may raise an exception here. Except block: if an exception occurs, the code in the except block is executed. You can specify the type of exception to handle, like zero division error in the example, or use a general except to catch all exceptions. Else block: if no exception occurs in the try block, the else block is executed. Finally block: this block is always executed, regardless of whether an exception occurred or not, and is typically used for cleanup actions like closing files or releasing resources. Conclusion: exception handling ensures that Python programs can deal with errors safely and continue running. It also improves code readability and helps isolate error-prone sections of code. What is the difference between try except and try finally? In Python, both try except and try finally are used for handling exceptions, but they serve different purposes and have distinct behaviors. Try except: the try except block is used to catch and handle exceptions that may occur during the execution of the code inside the try block. If an exception is raised, Python looks for an appropriate except block to handle the error. If no exception occurs, the except block is skipped, and the program continues normally. Example: try x equals 10, 0 # this will raise a zero division error except zero division error print cannot divide by 0 here. If a zero division error occurs in the try block, the exception is caught by the except block, and the error is handled gracefully. Try finally: the try finally block guarantees that the code inside the finally block will always execute, regardless of whether an exception was raised or not. It is often used for clean-up actions, such as closing files or releasing resources. The finally block is executed after the try block, whether an exception occurs or not. Example: try file equals open example.txt, a # code that may raise an exception finally file.close # this will always execute, ensuring the file is closed. Key difference: try except is used to catch and handle exceptions. Try finally ensures that code in the finally block is always executed, regardless of exceptions. In summary, use try except when you need to handle exceptions and try finally when you need to ensure certain actions, like cleanup, always happen. What are some common built-in exceptions in Python? Python has several built-in exceptions that are raised when errors occur during program execution. These exceptions help developers identify and handle specific types of errors. Below are some of the most common built-in exceptions in Python. Syntax error, raised when the Python interpreter encounters incorrect syntax in the code. Example: if true print hello, #missing : type error, raised when an operation or function is applied to an object of inappropriate type. Example: result equals 5 plus 3 # cannot add a string an integer. Value error, raised when a function receives an argument of the correct type but with an invalid value. Example: int abc, # cannot convert a non-numeric string to integer. Index error, raised when trying to access an index that is out of range for a list or other sequence. Example: me_list equals 1, 2, 3 print my_list 5, #index out of range. Key error, raised when trying to access a key that does not exist in a dictionary. Hash example me underscore dict equals a 1 print my underscore dict b hash key not found 0 division error raised when dividing a number by 0. Hash example x equals 5 0 hash division by 0 file not found error raised when trying to open a file that does not exist. Hash example open non-existent underscore file.txt hash file not found. Conclusion: understanding common built-in exceptions allows you to anticipate potential errors and handle them appropriately using try-except blocks, making your code more robust. How do you raise a custom exception in Python? In Python, you can raise a custom exception by defining a new exception class, typically derived from the built-in exception class. This allows you to create specific exceptions tailored to your application's needs and raise them when certain conditions are met. Steps to raise a custom exception: define the custom exception class. You create a new class that inherits from the base exception class or one of its subclasses. You can also define an initializer, _init_, to accept custom messages or other arguments. Use the raise statement. You can raise your custom exception using the raise keyword, which interrupts normal program flow and triggers the exception. Example: #step 1. Define a custom exception class invalid error exception. Def _init_ self, message equals age is not valid, self.message equals message super, _init_ self.message. #step 2. Raise the custom exception def check _age, if age less than 18 : raise invalid error age must be 18 or older else print age is valid try check _age 15 except invalid error as printf error. Explanation: the invalid error class is defined as a custom exception, inheriting from exception. The check _age function raises the invalid error if the age is less than 18. The exception is caught in the except block, and the error message is printed. Conclusion: custom exceptions allow for more granular error handling and better control over how errors are raised and managed within your application. What is the difference between assert and raise? In Python, both assert and raise are used to handle errors, but they serve different purposes and are used in different scenarios. Assert: the assert statement is used for debugging purposes and checks whether a given condition is true. If the condition evaluates to true, the program continues as normal. However, if the condition is false, it raises an assertion error exception. Assert is often used to validate assumptions made in the code during development and testing. Example: x equals 10 assert x greater than 0 this will pass assert x less than 0 this will raise an assertion error. In this example, if x less than 0 is false, an assertion error is raised. Key points: primarily used for debugging. It can be disabled globally with the optimize flag, meaning assertions are not checked in optimized code. Typically used in development to check conditions that should always be true. Raise: the raise statement is used to explicitly throw an exception. You can use it to raise both built-in and custom exceptions in your program. Raise allows for more control over exception handling compared to assert, as it can be used in production code to raise exceptions intentionally. Example: x equals 1 if x less than 0 : raise value error value cannot be negative. In this case, raise triggers a value error when x is negative. Key points used to trigger exceptions explicitly. Typically used in production code to handle errors. Custom exceptions can also be raised with raise. Conclusion: assert is used for debugging and checking conditions during development. Raise is used for explicitly raising exceptions in response to error conditions in the program. Thanks for watching the video till the end. If you liked the video and haven't subscribed yet, please hit the subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. In comments you can share the topic of your interest. Our team will prepare the video for you.